So welcome everyone. Today we're starting with our first live streaming series focusing on hexagonal architecture, the why. So essentially to get a better understanding of what is the purpose behind hexagonal architecture, why do we use architecture, how can we even transform our project, which was, let's say, maybe an MVC application, into hexagonal architecture, and why should we even do that? So I do want to say that this session will be interactive. So this means you'll be able to ask comments in live chat at any time. So as I'm drawing through the a sample project, I will also be periodically looking at comments and essentially trying to answer them real time as much as possible. So I'm really looking forward to hearing from you. And also, just before we get started, these are also some further additional reference material which you can look at later if you want to learn more about hexagonal architecture. But now let's get right into it. So I'm sharing my Miro screen. I hope that everyone can see it. Feel free to write any comments in chat. I hope that the font and everything else is fine. So let's get started with the actual scenario that we have here. So we're a software, there's a development team within a pizza shop company, and up to now they were doing all of their pizza ordering via phone and via email, and now they've decided to actually build an eShop so that they can sell pizzas online. And as part of the requirements, we have some simple requirements initially. We want to make a system whereby the customers can browse pizzas, can order pizzas, and can also order cancel orders. Also, here is just some notation that I'll be using throughout the project here, throughout these diagrams. So the first version that the development team develops is a very typical MVC application. This means we have a user, like the customers, who will be accessing the MVC application, and the MVC application will essentially contain everything, the views, the business logic, the data access, and here we are accessing the database. Now, what happens is that over time we have certain challenges that are occurring. So there is essentially more and more business logic. Sorry. I seem to have a connection issue, so I'm just retrying again. Okay. So we have increasing requirements and essentially complex business logic. And it's taking longer and longer to test. I mean, manual testing takes a longer time. So then the team is trying to solve this problem, and they get the idea that perhaps they should introduce automated tests. So in the next version of the system, we're going to be introducing automated tests, and these automated tests will be calling the MVC application. Okay, so let's see what we've improved upon here. So the automated tests help reduce manual testing time. Okay, great. So let's see what happens next. Again, we get the problem that there are again increases in business requirements. Again, business complexity. The problem is that there are more and more test cases. So these automated tests, which were initially quite fast, I mean, they are calling the UI, but now they get slower and slower simply because there's so many test cases. And these UI tests, which are in Selenium or Cypress, are essentially slow to execute. And also, since they are using the same database, it means that we need to have, tear down between each of the tests. And again, all of this is contributing to an increased test runtime. And the question that the team is asking themselves is, does it really make sense that we are testing all of these different kinds of business logic through the UI? Can we perhaps test the business logic separately, not through the UI? And that way, maybe we could help keep, the separation between the UI and the business logic. This is when the team realizes that perhaps they should move to the standard 3-layer architecture, whereby they're going to have essentially the MVC app. So they're going to have some kind of views, controllers, views. So this is the part that's handling the whole UI part. Let me just fix the spelling. So the UI. And below we have the business logic. And we have the database access. And this is probably the most common architecture that many development teams are currently using around the world right now. And indeed, the whole purpose of this live streaming session is to show how and why we're going to move from this later to hexagonal architecture. What problems does it solve? And we will be going through the problems one by one. So, since the team has introduced this kind of layering, it also means that they are able to have tests. So some tests still do remain in terms of calling the UI, but certain tests can call the business logic directly. So we've achieved a very important point here, is that we have achieved test speed up. Because business logic tests, so business logic tests are executed directly, not through UI. Okay, great. Everyone is really happy about this. Also, so the questions are there any other problems with this kind of architecture? Well, not yet. At least it's not yet visible to the team. But let's say we end up with a next business requirement. So the business requirement is some third-party system wants to call our eShop. So as we mentioned, we are making a pizza eShop, but there's another really big global company, and they are essentially they have their own e-commerce website, and they are selling various kinds of food to customers. So they could be selling lunches, dinners, desserts, etc. And additionally, they would like to sell pizzas. So they've reached out to our pizza shop company, and they said, we'd like you to become one of our pizza suppliers. Can we integrate with your system so that when our customers make orders for pizzas, that it can go into your system? And here we see the question is how exactly will that be executed? So I'm just going to get the symbol for the external system, and we're going to need to use it in the next iteration of our diagram. So we have that big company, and they want to integrate with us. The question is, how will they integrate with us? Can they call our UI? Well, they say they don't want to do that. They don't want their employees clicking on our UI. Instead, they want a system-to-system communication. So this idea is not going to work. So then the next idea is, can they maybe execute our business logic? That would mean that we would have to send them out DLLs or assemblies. Well, no, we don't want to do that either. So the solution in that case is that we agree with them that perhaps we will be communicating via, let's say, some kind of service. Maybe it's going to be SOAP or REST or something. So for now, I'm just going to say that we agree that it's going to be a REST API. So that means the communication is that there's a REST API here, and that REST API is calling our business logic. And here I'm just going to rearrange the diagram just so that we can better see all this. So we have the users, we have the tests which are still targeting our MVC app, but we also have this new REST API, which is currently being used by the third party, essentially website, who are calling our system in this way. Okay, great thing. So we've now essentially introduced a REST API. REST API to enable third-party systems to communicate with us. And that REST API is delegating to business logic. Later, there are some other companies as well who want to interface with us, but they don't want to interface via REST. They have some older systems and they actually prefer to use SOAP. So this means that we're going to have some SOAP APIs as well. So some kind of SOAP service that will be used by others. Okay. The next question that arises is, okay, and this SOAP service is also calling our business logic. The next problem that we're faced with is how do we know that this, SOAP API is working? Sorry, the REST API is working, or is our SOAP service working? Do we just ship it to the third-party system and let them test, or perhaps we should be doing the testing? So we also should be introducing automated tests there as well, which test, for example, the REST API endpoints and just make sure that we have the right connectivity. I like the question, so I'm already seeing some questions. So in chat, so hello, sorry, yep, hello, and who still uses SOAP? I like that question. Not that many people, but there are still some companies who are using SOAP. And even some companies who are using FTP or various other kinds of really, really old styles of communication. And this is another reason why it's really important to have this kind of separation, so that regardless of which protocols or something is chosen, that we can support it. Yeah. And again, I do want to encourage everyone, feel free at any point to write any additional comments or questions in chat. And if you've had any experiences with this as well, feel free to add anything. So let's continue on. So now that we have this, the next challenge that is also occurring is that our team is realizing that the MVC app is not user-friendly due to server-side loading, whereby like the whole page is loaded, but instead they would prefer to use to make a React application, for example. So let's see how we're going to do that. So our team is going to be making some kind of a React application, and let's see where it's going to go. So our React app would connect to our REST API. So there we go, problem solved. This is our own internal React application connecting to our REST API. Great. But now let's see what else is happening. Notice here how we have REST API, SOAP service, and we're still maintaining our old MVC app because the React app is not yet finished. So we have all of these ones, and they are referencing business logic. Now, this business logic is again getting more and more complex, and sometimes developers are accidentally referencing too many details from the business logic layer. So let's look at that problem. Accidentally referencing business logic details from the UI, because from the REST API, SOAP, and from MVC App controllers. The reason why this is possible is because each of these, they have full, reference to the business logic layer. So this means they can directly call whatever they want, the order entity, the customer entity can invoke absolutely any methods. There is zero control. And what happens is that then developers even start writing if-else statements and various other kind of logic at this layer. So business logic somehow is no longer just here, but it starts being spread out here and here and here. And these ones, the REST API, SOAP service, MVC app, themselves become possibly inconsistent. So the question is, do we really want all of these to directly reference our entire anything from our business logic, or perhaps do we want to restrict the access? So I'm just going to make this a bit smaller. And let's see if we can restrict access to our business logic so that not everyone can do anything that they want. And here I'm going to be introducing some kind of an interface. So I will label it in this way, and let me just move this down so that we have space. Okay, so what's going to happen is that essentially all of these will be referencing some kind of API. So this is some user side, sorry, I'll call it the ordering API. So this one will essentially expose the key methods that we can browse pizzas, that we can order pizzas, that we can cancel pizzas, and that's it. It's very, very minimalist. And our business logic will implement whatever is required by that API. Okay. The point here is that the presentation here can no longer access anything from business logic. They are restricted to what is provided by this interface. So I would say clear separation between, the presentation, like REST API, so MVC app, and business logic. And it's separated due to the API. Okay, great. So we've already made an achievement, and let's look at some other comments. So yeah, FTP, I like this comment. I'm also going to add this into the diagram. I know it's getting bigger, but let's see how this drawing is going to go. Maybe I will put it somewhere at the end that another company contacts us, they want to interface with us, and they have a really, really legacy system. So they actually require us to communicate via FTP. They're going to send us files, and we need some kind of FTP server. No problem. We can do that with this. There they are, they're sending it, and we can also write automated tests targeting our FTP server as well. So thanks for that. I really like it that we can improve the diagram in this way together. Okay. Yes, so that's an example that we can integrate even with legacy applications. So is this going to be recorded and available later? Yes, it is being recorded immediately right now. The only difference is availability of chat. So if you want to ask questions or make comments, basically it's via chat right now, but you can if you watch it later as well. I like this. There are some banking core services that use SOAP communication. That is exactly correct. So SOAP is still used, and this is yet another argument why we need to have this kind of modularity in our architecture, that we are not coupled neither to REST or SOAP. Maybe we could even have GraphQL or anything else. Okay, shouldn't the business logic tests attach to the API too? Excellent. This is a really great comment. As we can see in my previous diagram, the tests were targeting the business logic layer directly. Here, since we introduced this ordering API here, right now, I'm glad that you pointed that out, then our tests will actually be calling our ordering API. And if we look at this image here, we can see that our tests are at exactly the same level as the REST API, as the SOAP, etc. So they are all actually interacting with the business logic strictly through the API. So that's an excellent one. Thanks for that. So I updated the diagram now. Okay, great. We did a lot of improvements now. So I know that this diagram is now becoming much harder to manage. For purposes of going further, I'm just going to reduce it in scope above, just for purposes of drawing. So I'm going to delete the SOAP, the REST API, and I'm going to delete the FTP, and let's just have these two is enough, and we're going to continue on below. But as you've seen, you could have however many you wanted of these, presentations essentially. So the question is, what problems do we encounter next? Up to now, you've seen we've just been focusing on this side above. We weren't really focusing on this other side below, which is the whole database access. And as we know, databases do tend to be, really important as well. Now, there were some challenges that occurred. Our data access was using ORM, and we needed to upgrade the ORM. This caused breaking changes everywhere. So since our business logic was dependent on the database access, it means the business logic was using the ORM entities and ORM repositories everywhere. And upgrading the ORM would cause so many breaking changes to our business logic code. And this is actually not a made-up story. This is something that I've also personally witnessed in a real-life situation with a team. So let's see what's going to happen next. Okay, I'm having a bit of issues again. Sorry, with the connection today. So let's continue on. That was not the only scenario that occurred. Team decided to change ORM or switch to micro ORM because the current ORM was maybe too heavyweight. They weren't satisfied with the queries generated by the ORM, so they wanted to maybe write SQL themselves. Or even deciding to switch to a different database. So maybe they were initially using Postgres, but then they had some discussion and realized that perhaps MongoDB would be a better choice. Or we also could have the situation that the database server was unavailable for whatever reason. So let's say the database server on the test system was unavailable and all testing was blocked or something like that. So we can see here a lot of problems which are all stemming just because of the fact that our business logic is directly coupled to the database. And any of these changes, for example, these breaking changes, it would mean that during the time that this breaking change is in progress, that all developers are fully blocked. They cannot make any business logic changes at all. Or even here, testing on the test system. When the database is not available, then QA engineer might be fully blocked in testing. Also, automated tests which are hitting the database can't run. Oh, and also on the topic of database tests, I do also want to mention that our test suite has slow execution time due to the database. Imagine if we had, okay, initially maybe we had 10 tests. Later we have 50 tests, 100 tests, thousands of tests because of all of our business logic scenario. And each test is directly hitting the database. It means that our test suite is now could be taking several minutes to execute. So this particular test suite is slow because we can see here that it's indirectly depending on the database. So the question is there a solution? Now, before I go on, let me see also the comments. So how about a single point of failure? So feel free to clarify, but my understanding is if this is relating to the database is becoming a single point of failure and also a single point of blockage for the whole team. Yes, we may introduce some other type of database like Elasticsearch or Redis for cache. Exactly. We might be replacing our, let's say, Postgres database by Elasticsearch or Redis, or even, switching to a completely another type, or even using, two databases, essentially. So yeah, basically the usage of NoSQL. So we've just had a discussion that yes, we have this situation that we may need to switch to a database, and this is causing such a huge pain. The question is there any solution to this kind of problem? So let's see, the team was discussing it. How can they solve it? So they are thinking, how can we eliminate this dependency on the database? Can we maybe replace this real database by something else which is like a real database, but which is in memory? In that case, we don't care about which technology is used by the real database or whether the real database is active or not. But we have this kind of very reliable simulator. It's essentially like a mock fake for our database. So let's introduce that. So we could introduce some kind of mock database. Okay. Apologies, I'm just going to draw it above. Sorry, I need to just make changes here. So the issue is that this database access code, this was the part which, for example, had the actual ORM code or whatever other mapping code. And we said we don't want business logic to depend on the ORM or SQL or whatever else we have. But instead, we want to introduce something in between. So let's see what is the business logic going to depend upon. Let's say we have some kind of a placeholder. A placeholder for our persistence. Some kind of persistence interface whereby we specify that we are interested to maybe add an order, remove an order, update an order from the persistence mechanism, but we don't actually care about the underlying technology. So the business logic is now depending just on this interface. And then the choice that we're using a particular database and or SQL, whatever, would simply implement that interface. So maybe we have one kind of database, which is, let's say, Postgres. So we have, let's say, Postgres persistence implementation, and maybe it's using Hibernate or whatever. I mean, I'll just put ORM. Maybe we could be using MongoDB. And again, it is implementing. And let's see, did we have anything else? Or we could have Elasticsearch or whatever else implemented. So this solves the possibility for multiple implementations to exist. But we also mentioned that imagining the case that there is no database available, or we want our tests to run fast, and that there would be some kind of like mock or fake persistence implementation. And that one, it does not have any underlying storage. It is purely in memory. Now, I do want just to be more precise here. Okay, so we're focusing, I mean, only on business logic and what's below. About these arrows, because this is where it can get a bit confusing. So business logic, we could say it is using the persistence interface. So this is like users. So business logic uses or calls the persistence interface. Whereas these others, like the mock, fake persistence implementation, or Postgres implementation, or MongoDB implementation, we could say they implement the interface. So we're reading a bit in reverse. They implement the interface. And here I'd also want to say that somewhere with business logic, we're implementing the order API, whereas the word users is the presentation is using the REST API. Okay, now since we've done a lot of drawing up to now, I want to go back to chat to see where we are. Okay, I really like this question because I've seen it so many times. How many times in your experience do you switch database from Postgres to MySQL? For your domain, agree to add no SQL, but it's another topic. I agree with this. I would say in terms of what is most common, the part that is most common is, for example, using an ORM and then having to upgrade the ORM is a common issue. The other also common issue is the test execution impact of the database. So those are actually the biggest problems, and I would say they are the strongest motivators for why we want to switch to hexagonal architecture, whereas this one, completely switching to a different database, I know in practice it tends to be rarer. But again, I'm sure there could be different answers to this question, how frequent is it? Business logic should persist via interface contract so that we can use dependency injection to inject database, file, whatever. I like that file was also mentioned so that I can add it as well, because maybe we're not even going to use a database at all. Maybe we are going to have a file system that we are storing just some data on files. So that's another possibility. And I like the comment here about dependency injection. That's exactly correct. So we can use dependency injection injection frameworks or any other mechanism to inject the persistence implementation, whichever one, and we can even configure maybe in our startup or configuration file which of the actual persistence mechanisms will be used. So that's exactly correct. Business logic code does not depend on any of these implementation from a coding perspective, but instead at runtime we can configure which of these will actually be used. So that's a great comment. Then a mock database or fake object database could be used. Yes. So the mock or fake database object, I would say their primary usage is for the purposes of tests. If we can just remember how we have tests up here, the tests which are calling, the ordering API, and ultimately when we're testing, we would want to use, the mock or fake persistence implementations. Apologies that there was ORM here. So that's exactly what would be used. But even at runtime, we could be using fakes. So one example of that is, suppose you want to deliver a very fast customer demo and maybe you haven't even chosen your database yet or don't want to spend the effort to build a whole database implementation, but you could work quickly with a fake, or even if the database is down or let's say on the test system, whatever. So you could even use fakes, not just for automated tests, but even to configure them to be used during actual execution. Okay, data syncing distributed state could be interesting. Okay, so I see here the mention about distributed systems. That's yet another good topic. At the moment, for the purposes of this session, we will be staying only with the monolith application, but in the future, I think it would be nice to also explore hexagonal architecture within distributed systems, like with microservices. How does it work together? Okay, nowadays testing with the real database infrastructure is easy enough with test containers. Okay, so that has become a point of controversy and where there are different opinions. So back in the time when hexagonal architecture originated, this possibility did not exist at all. The only possibility was either you have the real database or you have some kind of mock fake, and that's it. There weren't any test containers. So from that perspective, that was, I guess, the origin of a very, very strong separation. And similarly, we can see even with Uncle Bob, who essentially built up on hexagonal architecture with cleaner architecture. And again, he's using all of the examples are essentially replacing the database with an in-memory database. Then came along test containers. The challenge that still remains even with test containers is one challenge is still the runtime. Again, the difference between running the tests with test containers versus if we were running purely in memory. So we have the difference there. And there's also another difference. If we architecturally don't introduce this kind of separation, like business logic, persistence interface, and separating it from implementation, it could occur that developers again start mixing business logic and database concerns, which has issues for modularity, maintenance, and stuff like that. But overall, thanks for raising that topic. I do know that there are different opinions there. So we also have the topic about inversion of control. Exactly. So here, what we have done is basically inversion of control. The business logic does not depend on any of these implementations. It depends only on the interface, and it does not care or know about any of this. So since I mentioned that comment, I do want to add something here just to distinguish between, I guess, the grouping of everything. Let me see. We end up with this kind of grouping. I'm just going to bring this, make this white and bring it to the front. Thanks everyone for your patience. Okay. We essentially end up with this kind of thing, that this is what we are controlling. This is like the heart of our system. And this is what Alistair Cockburn calls the application. Whereas this is just some technical names, and these are the, let's start maybe from the top, driver ports or user side ports, and then I'll continue with the comments after this. This is just, okay, introducing some terminology since we've reached this point in the drawing. So we have the driver ports, and we have the driven ports. This is the or it's called the server-side ports. And these things above, like the REST API, MVC, tests, everything that's at this level, we call them the driver adapters. Like they adapt to some technology. And also below we have the driven adapters. I guess I'll write the word here. Okay, so I just wanted to point out that terminology as well. Oh, and also a reminder to myself, the tests here. I'll get to that in a minute, but let's continue on with the. Okay, but a bit expensive. If you use unit or integration tests, I'd prefer fake objects. So the discussion regarding which kind of test doubles to use, I mean, the more generic word here is test doubles. So I just want to add that as a note as well. Whether we're going to have a mock, fake, stub, spy. That's yet another discussion of its own. I personally tend to use fakes because I find then that I get reusability across the tests and I get really high fidelity. And also in the book Software Engineering at Google, they also tend to recommend using fakes as the test doubles. Do you have an example where the ordering API interface would be implemented by other classes than BL classes? If there is only one implementation, why use an interface? I really like this question. So in general, it is true that there would be only one implementation. The question is, if there is only one implementation of the ordering API service, why would we even have this interface at all? I will leave that as a thinking question for the audience. I will note it and come back to it later. The question is, why do we even need this interface if there's just one implementation? So feel free to write any perspectives in chat. I will come back actually later to this question. Okay. So even if you don't change the database or the test containers, make testing easy, you still would have the problem of business logic leakage into the database layer. I really like that comment, because that's the whole point. The purpose here is not just test execution time, but how are we modeling the system? And in the same way that we have problems when our UI logic becomes mixed with business logic, and remember, we solve that by having some kind of interface so that presentation cannot just mix freely with the business logic. Similarly, the existence of this kind of interface forces developers to have this kind of separation. If this interface did not exist, and again, if we could directly depend on it, then developers could write data access code anywhere. So it's essentially indicating poor separation of concerns. So yes, this was a great comment. And to add on, shielding the business logic with interfaces tests are regression tests also. So that is right. I mean, here, as when we go above to these tests are hitting essentially our application, testing it through this API. And we are sort of protecting the business logic from any other concerns, regardless of which side we're on. Try test against the mainframe. Okay. Question is it the case? Okay, to be, I guess, more creative, our system could integrate with the mainframe. So if we needed to maybe get some data from the mainframe or something, we could write an adapter. Like we could also have an adapter for over the mainframe. So I like this, not many people mention it. We need an interface for it because we want to test it. So I see multiple comments now about testing and interface, and I will get to tests for this interface as well. So maybe I'll do that right now. So as we can see here, how we have tests which are testing the essentially the driver port, so they're testing the application in this way. And here we will be replacing the persistence interface with mocks or fakes. But the question is, our tests are then spanning pretty much only this. Maybe I should even color code it. I will do a copy paste and color code. just that we are aware of what exactly our tests are spanning. Okay, maybe I will use this as some kind of color. Okay, maybe a different one. Let me see. Okay, I'll choose green. So our tests are hitting here. They are essentially testing the whole application layer, and they happen to be using these mocks and fakes in the implementation. As we can see here, we have absolutely no tests targeting this if we look at all of this above. So what I need to emphasize here is that we have tests, that we write tests, and we can see the symmetry. Okay, these are, I mean, different kind of tests, so I'll choose a different color. In the same way that we have tests which are targeting the ordering API, so targeting the driver ports, similarly, we are going to have tests which are targeting the persistence interface. So let me choose a color there. And it's a bit challenging to graphically represent it, but when we write these tests against the interface, it means at runtime that we can apply these tests to any implementations that we have. So we write tests once for our persistence interface. So we write a test that when we add, let's say, an order, that we can retrieve back the order with the same data. We're writing it against the interface. And then at runtime, when we execute those tests for that adapter, they would be executed against all of these, like against this as well, essentially. So that's the part about testing. And since there's a lot of colors, I will go back to the uncolored version. And I'm going to just add the tests here, that we have a reminder that we have tests which are essentially targeting the persistence interface, and then at runtime they are executed against all of these adapter implementations. Is application the application layer? This is a good question. So often there's a lot of confusion regarding the word application, and this is why I didn't even use the word application at all until the very end of this session. So many people, when you say the word application, to them it might mean the whole thing. So it might mean the whole MVC application or the whole React application, and essentially involve everything. So that's the way some people interpret it. The way that the definition of application within Alistair Cockburn's hexagonal architecture is exclusively this. So application essentially encapsulates the business logic, and it also has user-side ports and server-side ports at the boundary, and that's it. That's the application. So it's like a wrapper essentially around business logic to protect the business logic from the external world. Some people may call this application, again, due to all of this confusion about the word application. I like to call it, well, this is not the official word, but I like to call it application core, and I think I've seen that somewhere as well, just that people are aware due to the multiple meanings of the word application. code it like you would maintain it. So a big motivation behind hexagonal architecture, which does happen to be what we've reached right now, is maintainability and testability. I can see one point of having the ordering API interface. One can start development using it without even having an implementation. That is exactly correct. It could mean that suppose we have a front-end team, they're making a React application, okay, and we're making a REST API, and maybe some other external systems again need to interface with us, whatever, but we have not yet implemented the business logic at all. This could mean that essentially by having these interfaces, we do not even need this to be implemented, but we can still immediately start working on our adapters and even writing the adapter tests, even though this implementation does not exist at all. So that is exactly one motivation for it, and I would say it's quite an important motivation for it. The other motivation is it prevents leakage of the business logic. So if the REST API, MVC app, if they can only have access to an interface, now interface is quite restrictive what it exposes, we could have this interface might consist just of three methods: create order, cancel order. Our business logic might have hundreds of classes in it. The presentation layer, by depending on the interface only, would not have access to those 100 classes. So the UI, the presentation concerns cannot be mixed. It prevents the mixing with business logic, so essentially enforcing higher modularity. So just to summarize, by having this as an interface, it means that we can immediately start writing our adapter tests even in parallel, and we just mock this out. So that's one benefit, and the other benefit is it really forces a strict boundary between the presentation and between the business logic to prevent mixing of the business and the presentation logic. And even though I use the word interface here, there are various ways of implementing it. Maybe we might get to it at the future points. Okay, shouldn't that be the main layer instead? So this business logic, we could call it the domain layer, and that's the terminology that's used by Uncle Bob. So Uncle Bob, he calls the business logic, he calls this the entities or domain layer, and he calls this the use cases layer, and he calls this the gateway interfaces. So yes, it's just different namings. And if you look at the evolution, well, hexagonal architecture is the foundation for all of them, and just as we go on to onion architecture and clean architecture, some of the names inside could be different or more specific. Having an interface for ordering API allow the parallel development. Business logic does not need to be ready in order to start the REST API, and vice versa, as long as they only depend on the interface. That's exactly correct. So this ordering API, it is essentially representing the use cases of our system. So I'll just write just the word, use cases here. Whereas these ones are like gateways. And when we're modeling the system, we should be starting at our use cases. And this is exactly allows us to work in such a way. Can you share your diagram, please? Okay, I will have a look, and I might comment later on YouTube. Ordering API interfaces throw exceptions. Okay, I might put that as a to-do for a subsequent session, simply because we are getting towards the end, but I will put that to-do, throwing exceptions. Okay, let's move on. The good thing of having these interfaces is that you are describing behaviors instead of integrations. So that's correct. These interfaces help us think about contracts rather than the underlying technology. Thanks for that. I'm glad to hear that you enjoyed this presentation. This way, it doesn't matter what changes might happen beyond those interfaces, because the behavior stays the same until a new behavior is needed or changed. So we could say that these are representing contracts, and that those contracts are representing some kind of expected behavior behind the interface. So sorry, both of these are essentially contracts. And for the adapters, they are concerned with specific technology infrastructure concerns. Okay, infrastructure concerns, and I will, okay, same applies here. So it's completely different concerns, and they change for different reasons. So that's yet another reason for this separation. The application core is changing due to different changes required in use cases and business logic, whereas the adapters, their reason for change is due to any technological changes or technological concerns, which is completely different concern compared to our business logic. Are the input adapters active or reactive? The request should invoke the interface that invokes business logic, or would business logic be pulling or maybe polling the requests? I'm not sure if I fully understood that one. Maybe feel free to clarify, but I will try my best to give a short response now, but feel free to clarify. I will just explain what's happening as follows. So when we have our REST API controllers or the MVC controllers, we can, via dependency injection, inject the actual implementation of the ordering API. So, I mean, the actual code, it's dependent, it's calling the ordering API. So it's saying like ordering API, dot create order, ordering API dot cancel orders. So the actual controllers are literally calling the API in the source code. Then at runtime, through dependency injection, there's the dependency injection of the actual implementation of the ordering API, which is within the application, and that one that's the actual execution. So just to summarize, these controllers are directly calling the ordering API. Business logic is directly calling the persistence interface. So somewhere within business logic code, we have a call towards our persistence interface, which tends to be called repository. For example, order repository interface dot add order, order repository interface dot update order, dot delete order. So it is calling it, directly calling it. Okay. So yes, there are cliffhangers, since we do have some multiple open questions, which I may use for subsequent live streaming sessions, since this is just the first one and this is like we're just getting started. we need ordering API to instantiate the whole application with different drivers, and this is not the concern of the business logic. That's exactly correct. Indeed, we have a completely another separate thing. It's called the composition route. Now, this is not even, it's not part of the hexagonal architecture diagram, but anyway, it exists. So the composition route is aware of the application core and of all the adapters. So that's actually the only thing that is aware of everything that exists, and then it is able to configure at runtime essentially all of these points. One moment, sorry. This is where there's dependency injection and here as well. Okay. Is use cases also stand for driver ports? So I've put here the different terminology which tends to be used synonymously. So driver ports, user side ports, use cases. So you can think of it essentially all of this here. Okay, thanks. Okay, I'm glad to hear that. So since we did already go over the 1 hour, I do want to say thanks to everyone again. Thanks for all your comments. Okay, I did see yet another comment. I'll add that to the to-dos. So this was just the first of our live streaming sessions about hexagonal architecture. And I really hope that you enjoyed this and that you found this useful. As I mentioned, this is just the first live streaming sessions. I do plan on having subsequent ones. So for the next live streaming session, I would like to see how all of this transformation that we reached up to now, how does this relate to Alistair Cockburn's article, and that we can then have a much better understanding of it. And the other parts that I would also like to continue on in our next sessions is further complexity, let's say, regarding the driven adapters. So not just databases, but how do we deal with RabbitMQ, Kafka, with integrating with PayPal? You know, how do we do all of that in a hexagonal architecture way? And I'm also always open to any comments, questions, because as you can see, it is interactive. So whatever you say or write may affect what we do in the future. And of course, here I used an e-commerce example. In the future, if you would like to see anything else, you know, feel free to let me know. So I would like to say once again, thank you everyone for watching, and I wish you all the best. And just to share again, I encourage you all to look at these resources, and also feel free to connect with me or follow me on social media. So thanks a lot everyone, and I wish you a good day. Thank you. Bye.